Alright guys, today we're going to talk about half-life. And half-life is defined as the amount of time that it takes for 1/2 of a sample to decay. Alright, for instance, if I have 100 grams of some radioactive substance, how long does it take until that has decayed down to 50 grams? That amount of time, that is a half-life. Alright, so the easiest way to teach a half-life is actually to start with an example. Alright, so that's what we're going to do. We're going to start with an example here. We're going to start with an example of radium-226. We're going to start with an example of radium-226. Radium-226 has a half-life of 1,590 years. 1,590 years. And so we're going to use that half-life as our starting point. Alright, and so let me move my screen here a little bit. Move that radium to the top there. So let's say we're starting out with 100 grams. So our starting mass is 100 grams at time 0. Time 0. After a number of half-lives of 0, no time has passed. No half-lives has gone through. Alright, we still have 100 grams. And this is going to be our fraction remaining. We still have the entire thing left here. And I'm going to actually put another one here that is fraction decayed. Alright? So we can see all that, and 0 of it has decayed at this point. Alright, so after one half-life, alright, how much time has passed? One half-life? Well, one half-life is 1,590 years. So 1,590 years have passed for one half-life to occur. That means half of the substance remains. And that means 1/2 of it has decayed. And we're now down to 50 grams. Alright, let's look at another one. Let's go further down the list here. So after 2 half-lives, how much time has passed? Well, we start with that original 1,590 right here. And we're going to double that. We're going to add another set of that. So we're going to add this here. And we end up with 3,180 years have now passed to get through 2 half-lives. That means we have 1/4 of that left. 1/4 of our original amount remains. And that means 3/4 of it has now decayed. We're down to 25 grams of our original amount. Likewise, we go down farther. We cut it in half again. We get down to 12.5 grams. And we now have 1/8 of our original amount left. That means 7/8 of it is gone. We've gone through 3 half-lives, and we have a total of 4,000. Right? Did I do that right? Yeah, 4,770 years have passed. And we can just continue this table on down. We would eventually go to 6.25 grams. And we've gone through 4 half-lives, we have a 16th remaining, and so on and so forth. Alright? And so that goes on and on and on. And what we would find, let me slide this out of the way, what we would find is that our equation looks like this. 1/2 to the n, where n equals the number of half-lives that we've gone through. 1/2 to the n power times the original mass gives me my final mass, all right? Now there's a much more complicated logarithmic equation that we can use for half-lives, but as far as we're concerned right now in this class, this is all we're worried about, that we can go through exact half-lives, through integer half-lives, and find out how much we have, all right? So what we're going to get out of this is ultimately a graph that is an exponential decay. And you should learn this in Algebra 1. But basically, we're going to get a graph that looks like this, which creates a bit of a paradox. And the idea that we never actually reach 0, because if I cut it in half and I cut it in half and I cut it in half repeatedly, I never actually reach 0. I just get smaller and smaller and smaller incrementally by half. All right? And this is exponential decay. Now, the reality is, in chemistry, things don't actually happen that way because we end up at one particle at some point, one molecule. But this is how this goes. All right, let me show you one more example. All right, we slide everything up here. All right, so if we use another example. Let me change pens here. We change examples. Let's say we're talking about ibuprofen. Ibuprofen serum has a half-life in the body of 2 hours. If a person takes 250 milligram tablets, how much is in their system after 8 hours? All right, so that means that at the beginning, at time zero, the mass in their system is going to be 500 milligrams, 250 milligram tablets. And we want to know, our question is, after 8 hours, how many milligrams remain? That's what we want to know. All right, so that's what we're trying to figure out, and let's scoot our question over there. All right, and so what we can look at is after 8 hours, how many half-lives is that in? Well, 8 hours total. If we've gone through, each half-life is 2 hours, that means we've gone, this is per half-life, we've gone through a total of 4 half-lives. We've had time to go through 4 half-lives. Well, it means we're going to cut this in half 4 times. So we start out with 500 milligrams. We cut it in half once. Half, all right, is going to be 250, and then 125. That would be half again. So this is 1 half-life, 2 half-lives, 3 half-lives, 4 half-lives. All right, and this is going to be 62.5, and this is going to be 31.25 milligrams left. And so that's how we would do it in a table format. We would just simply cut it in half 4 times. We can also put it in our equation, right? If we move everything over here, if we take our equation, our final mass is going to equal 1 over 2 to the number of half-lives, 2 to the n, and we've used 4 half-lives, times our initial mass. All right, so we work this out. My final mass is going to equal 1, 2 to the 4th. 2 times 2 is 4, times 2 is 8, 16, right? 2 to the 4th is 16, times my initial mass of 500, and that'd be milligrams. All right, and so 1/16 of 500, my final mass we'll find is 31.25 milligrams. And that's it for the basic introduction into half-life.